Lesson 5 of this chapter has us graphing linear equations and functions. So first we'll graph equations using that slope-intercept form, then we'll change slopes and intercepts of lines, then we'll identify parallel lines with using slope. We learned this a little bit yesterday about this slope-intercept form where we have y equals m times x plus b, where m is the slope and then b is the y-intercept. So for example, we have y equals 2x plus negative 2. Here's that y-intercept, so it crosses at negative 2, and then its slope would be 2. And here, for example, I see that it rose 4 and it ran 2, so it's a slope of 2. So for every 1 it goes over, it goes 2 up, and it follows that formula. So let's actually graph this equation out. First we need to turn these equations into slope-intercept form. This y equals something times x plus b. So I have 2x plus y equals 3, so let's get that y by itself. Let's subtract 2x from this side, 2x from that side. I could write it like this, y equals 3 minus 2x. I'm going to write it like this, y equals negative 2x plus 3. See, I took the negative 2 and I put that in the front, and then I added the positive 3. So this is the way I can solve it here. Let's start at the intercept. Our intercept is positive 3 or plus 3. So here's where we're going to be starting here. And since the slope is negative 2x, if I went over 1, I would go down 2. If I go over 1 more, I go down 2 more. Run of 1, rise of negative 2. Run of 1, rise of negative 2. Run of 1, rise of negative 2. If I go negative 1, I would rise actually a positive 2. Negative 1, positive 2 rise. And here we can see that I brought a room, so I can actually draw this line and get it right on that equation. Let's change slopes and intercepts of lines here. I think we're just going to focus on the slopes for this one. Intercepts are a little easier. So to get from one floor to another at the library, you can either take the stairs or the escalator. You can climb stairs at a rate of 1.75 feet per second, and the escalator rises at a rate of 2 feet per second, so a little faster. You have to travel at a vertical distance of 28 feet. The equations model the vertical distance, d, in feet. You have to travel after t seconds. So here's the seconds, here's the feet. Okay, so d equals, the distance equals, negative 1.75 times t plus 28. So you started at 28 and then you get closer and closer to that 0 distance left as we go. Same thing with this one. D equals negative 2t plus 28. So you both start at 28. So let's graph that here. So here's 24, here's 32, so the middle of that would be 28. Let's graph that in red for the first one. This is negative 1.75. If I can convert this into a fraction, it would be negative 1 3/4. But I'm going to do actually negative 7 over 4, so I can do rise over run. So 1 times 4 is 4 plus 3 is 7, so 7 over 4. I like improper fractions for rise over run because then I know what I'm doing. So negative 7 over 4. So if I run 4, which gets me here, I would go down 7. So that would take me to 21. Let's say this is 20, so 21 would be right here. One more run of 4, I would go down 7, so that would take me down to 14, which would be right here. Another run of 4, which would get me to 12, that would take me down to 7. And another run of 4 to 16 would go from 7 to 0. So here I am with no more feet to travel after 16 seconds. I've made it all the way through the stairs. So let's draw this line in red. So this would be the stair method. Now let's do the escalator method. I'll do escalator in blue. So I'm going to start at the same point, the 28 feet. So that's going to be in blue. Now my rise over run would be negative 2 over 1, negative 2. So I run 1 and I fall. So if I ran 4, I would fall double that. It would actually be 8. So that ratio has to stay the same. So run 4, fall 8, which would be 20. A little bit lower here. If I run 4 more, I would fall 8 down to 16, down to 12. If I ran 4 more, I would go all the way down to from 12 to 4, 8 more. And it looks like I'm going to get there pretty quickly. Let's do a run of 2 and fall 4 more. So run of 2, fall 4 more. So I went from 12 to 14. So here I am at 14. So let's finish this line. And we see because this slope was greater, we got finished with the escalator first when it was 14, and compared to this one when it was 16 and 0. So how much time do you save by taking the escalator? It looks like if this is in seconds, looks like we saved 2 seconds by taking that escalator. Now we need to identify parallel lines using slope. So parallel lines are going to be going the same rise over run. If they have a different rise over run, that means that one is sloping at a higher rate than the other one, and then you'll eventually cross. But if they're the same exact slope, those lines are never going to meet. So let's see if we can find 2 that have the same slope. This one would be rise over run, right? It would be a run of 3 and a rise of 1. So rise of 1 over a run of 3. So line number 1 has that. Let's look at line number 2. Line number 2 has a run of 1, 2, 3, 4, 5, so that goes on the bottom, and a rise of 2. So 2 over 5. Is that the same slope? No, this fraction is not the same as that. 1/3 is like 2/6. That's not 2/5. So far we don't have a match. Let's see if this third one matches with either one of these. So for this one it would be a run of 1, 2, 3, 4, 5, 6, and a rise of 2. So a run of 6 on the bottom, rise of 2 on the top, and let's see if either of those would be right. So here, this does not match up, 2/5 and 2/6. But what about 2/6 and 1/3? If you simplify 2/6, yeah, that would give you 1/3. So it shows that line 1, which is a 1 over 3 slope, and line 3, which is a 2 over 6 slope, these lines are parallel. So the blue line and the purple line would actually never meet if they were drawn perfectly. I think I might have drawn them a little bit off, but they would never meet in reality because they have the same slope. So we'll say lines 1 and 3.